Joining us today is Drew Walts, U.S. Army veteran and technical service manager for IRIS Incorporated, which specializes in the manufacturing of IR windows and ultrasound test kits. Drew is no stranger to the world of IR thermography and ultrasound. He holds the Level 3 Master Thermographer and Cat 3 Airborne Structure-Borne Ultrasound or ASU certifications. Drew's experience with IR and ultrasound spans 34 years, including his time in the military and while working at UE Systems and now IRIS. Drew also spent 9 years as a former lieutenant in the Stillwater Fire Department. I wanted to discuss the various facets of IR and to highlight IRIS's Veteran Assistance Program. IRIS is a veteran-owned and operated company that offers free training to veterans, which we will dive into in this discussion. Drew, many thanks for joining us this morning. Can you tell us a little bit more about yourself?
Well, Mike, thanks for having me on. My introduction to infrared actually started in 1981 with National Geographic had a special energy edition. The cover was lava scape palette, and it had this industrial thing, and you flip through, and they had pictures of people and buildings and cars, and it just really captured my imagination. And then when I got into the Army, I was a forward observer, and we had grayscale palette on our FLIR systems for our targeting system. So non-radiometric, meaning it didn't take measurements, just gave you hot spots because we really don't care about the target's temperature. I started with UE Systems years ago and got into the ultrasound side of things, and then started working on the side, hustles with a company out of Fishkill, New York, doing inspections of steam traps and Trump Tower and all the different buildings down in New York City. So I really had a great understanding of the use of infrared and ultrasound for steam. And then I got in the mechanical landscape, helped Amazon set up their program, integrating infrared and ultrasound together for mechanical applications and conveyor testing and a whole plethora of things. Then I started my own company in 2017. Got a call from Martin like a month into it, and I was already looking at the books like, oh, this is going to hurt the next couple months. And he's like, hey, I've got an opportunity for you. So I said, okay, I'll mothball my company till I retire. And came on board with Martin as training manager, wrote the level 1 through level 3 infrared certification course with my good buddy, Paul Goodbody over in the UK. And then wrote the level 1 through level 3 ultrasound certification for IRIS as well. So we've got 6 training modules that we have available that meet the ISO 18436 standard. And infrared, it also meets the SNT standards. And those standards are used by industrial segment to show that there's a competency level in the technology by the technician using it. And being a veteran myself and working for a veteran-owned company, our HR managers, former Army recruiter, our marketing directors, former Connecticut National Guard, our IT director is a Marine Corps guy. One of our sales guys is a former airborne EOD guy who, oddly enough, currently out for hip replacement surgery. But, we've got another IT guy we just hired on, former Army guy as well. Our guy in Latin American was a Chilean Navy officer. Our guy, Paul Goodbody, was a parachutist with the RAF. Martin, the owner of the company, was with the Royal Army, and he was a chief warrant officer. Our sales guy in the UK and Europe, he's former British Navy. So we've got a real tie to veterans and service. So, being a former firefighter as well and Army, just kind of piggybacked off of that. And that was a great opportunity for me to get into something after I got out of the military. But in this industry, we have a lot of veterans, and this training is not inexpensive. It can range anywhere from $1,500 to $2,200 just for a certification course. And veterans just coming out don't have that kind of disposable income a lot of times because that transition's expensive. You're getting new housing, you're moving, you're going here, you're going there. And we've seen a big uptick in the drone landscape for infrared use. So we've partnered up with groups like Vets to Drones, who currently they're doing a lot of missions up there in North Carolina for the post-flood. They do a lot of group work trying to resource other veterans in areas to work with CAL FIRE. And a couple of years ago when the storms hit the Northeast up there in Maine and Massachusetts and New Hampshire, they had drone operators that they were contracting out to go up to help with the relief efforts there. So we wanted to be able to help the veterans coming out And Martin came up with the idea of offering free certification, either in the infrared course or in the ultrasound course.
Very
And the
cool.
biggest uptick has been the infrared side because so many drone operators are coming out of the military service. So we've partnered with Vets to Drones, Drone Launch, which is a company that teaches the FAA 107 license up here in Lakeland, Florida. They send people our way as well. And, if we get veterans coming through, we also tell them, hey, why not talk to Drone Launch? They've got a great program. They don't teach you they teach you what you need to know for the FAA 107. They don't
Gotcha.
actually provide the test for that. You still have to go to an approved
Testing.
school for your pilot's license. So it's just a great way to give back to the community. We've seen a big uptick in our IR courses, obviously, from that. So far this year, we've enrolled, I believe it's up to 73 personnel into certification courses. And it gives that student the chance to take that technology and put it to an applicable skill, whether it's agricultural use of drone IR inspection, whether it's fire, search and rescue, wildland management for wildfires, transmission line testing is a big one. But the
Huge.
biggest application we generally see on the drone side is flat pitch roofs.
Oh,
Um,
B. Is
the
that
old,
for like roof inspections, I'm guessing?
Yeah, so everybody's had the experience of a roof leak at some point in an industrial building, or when you're walking in the mall, you see the buckets on the floor, especially after this last hurricane. There's a lot of places around still have
Right.
buckets underneath stuff. But those flat pitch roofs are great for holding water when the drains get plugged, and then the water infiltrates underneath the membrane. And the old school way was you had to get up on an A-frame ladder, 16 foot up maybe, and try to pan down with your IR camera to find the moisture. Well, now you can fly a drone, at 600 feet above that roof, and you can stitch the pictures together, and you get a great outline of where the actual moisture is infiltrating into the building. And it's just a really, really easy process to get that drone up and figure out exactly, hey, we've got an issue. And insurance companies are using it for that same thing, to help determine, hey, we've got post-storm damage, how much water infiltration's in the building. Hey, it's over 50% infiltrated. That's going to lead to structural issues down the road, further leaks, more damage internal. So they'll go ahead and approve the insurance claim for repair of roof and replacement of roof. So it's a
Wow.
lot of great things that come out of infrared when it's used
Absolutely.
properly.
Now you mentioned ISO in the intro there. So, what is the governing body for thermography? Is it the ISO compliant side of it, or is there a governing body or an organization, kind of like in the NETA world? You have NETA, the organization. Is there something similar in the thermography and ultrasound world?
Yeah, so it's not really a governing body that the certification follows. It's the standard. The ISO International Standards Organization put together several standards under 18436. Part 2, I think, is vibration, and then Part 7 covers infrared. Part 8 covers ultrasound. So that's the standard that we built all of our material to, because when I've traveled around the world teaching ultrasound in the past, I always remember 2009 in the Ukraine. The guy literally turned to me when I had said, well, this certification is built to the AS&T standard, American Society Non-Destructive. And he goes, through, but this standard here in Ukraine means nothing to us. So it was, kind of that aha moment. Yeah, here I am in Ukraine, and they don't really care about American standards. So the ISO standard is globally
Right.
recognized, whereas AS&T recently has kind of shifted over, and now they've got their ANSI, which is American
Yes.
National Standard.
Scientific, yeah,
Yes,
standards. Yeah,
international standards. So they've switched to CP 105 and CP 187 for infrared, but there is no actual standard for ultrasound, for
interesting.
airborne structure-borne ultrasound. There is for time of flight, pulse array, phase array, thickness testing, flaw detection. And, kind of when I found that out years ago with UE Systems, like, hey guys, there's not really the standard that we're saying that we're teaching to. It's a great course. Don't get me wrong, because I wrote the course in 2010 for UE, and it was a very, very informative, in-depth course about ultrasound, sound wave characteristics and stuff like that. But it wasn't an actual standard. So when
Gotcha.
the ISO 18436 Part 8 was released, I jumped all over it here at IRIS, and we rewrote everything to meet that standard. We had it reviewed by a third party company called Mobius. So they reviewed our level 1 and our level 2 materials and said, yep, you guys checked all the boxes, because there's a whole template of you have to cover this topic for so many minutes, this topic for so many minutes. So it is written out to a format that any company can pull up that standard and they can write the course so it covers the same material. Now, maybe the content's worded a little bit different, but the terminology, the science is all documented. And whether it's infrared or ultrasound or vibration or motion amplification, having standards for any of these technologies that we use in an industrial segment or for civil engineering side is really good to be able to say, hey, my personnel are trained to that.
Absolutely. And can you do, we kind of, briefly did a good overview of thermography. Can you kind of dive a little bit deeper into the ultrasound side of things? I find it very interesting because there's also airborne and structural. So can you kind of walk us through airborne and structural ultrasound?
Yeah, absolutely. So just like infrared is something we can't see with our eye and we have to have a device to see it, ultrasound is a device that hears above the human hearing level. So perfect vision, we know, is 20/20. And in hearing, the perfect human experience is 20 hertz on the low end to 20 kilohertz. Well, ultrasound starts at 20 kilohertz. Most devices that are used in the industry will have either some form of frequency tuning or they'll have a fixed band of frequency that they're testing at. And that's used for steam trap testing. You can hear the flow or the bypass of the steam through a steam system. I know growing up in New York, I had steam traps in my house. We had the old cast iron radiators, and it was kind of a comforting sound to hear that clank, clank, bang at first when it would start up. But when it started leaking out on the floor, well, that's a problem. So steam traps, they fail. They can become inefficient. So ultrasound will hear the turbulence. You can measure the discharge with it. Valves are another big one. The Navy was really big on instituting a 4-point test method on submarines using an ultrasound device to determine the decibel difference across the 4 test points, because if a valve's shut, there should be less decibels downstream of the valve body. So for valve testing, it's a great tool as well. Mechanically, when we get into rotating equipment, motor bearings have historically, the predominant test technology has always been vibration. Well, ultrasound will actually pick up damage to an outer race, inner race cage, or the ball bearings before they provide vibrational indications. But vibration will pick up soft foot and a whole bunch of other things, misalignment. So using those two technologies, you can get a good grip that, hey, my bearings, I'm already starting to get a problem. What's my harmonics? We record a sound wave, use sound analysis software. I can go all day on the sound analysis stuff, but you can find out really quickly the spacing of harmonics by determining what's my turning speed, what's the number of bearings in there, what's my coefficient table, and my harmonics will stack up at this value. If it's a bearing, it'll stack up at this interval. If it's an outer race. So there's a lot of great details we can get out of that bearing by listening ultrasonically. We can even provide a site the determination of when to lubricate based off of those bearing values. And generally, companies that have frequency tuning will tell you, hey, mechanically, we're going to dial in at 30 kilohertz. We can also do mechanical on conveyors, such as Amazon. I've got them or set them up so they can walk their line of 23 miles very quickly and very easily and listen to a bearing that's going bad in those rollers. And those rollers are stainless steel. They had a problem before at one of the sites that I first worked at where they were going out with the IR camera. And because they were stainless steel and their personnel were not properly trained, they were calling all these rollers bad because they were getting a reflection from the lights overhead on the roller, making it look like it was hotter than it actually was.
Gotcha.
So the ultrasound, when they're doing their leak routes for the pneumatic brakes on the conveyors, they can also find a bad roller. Maybe the finger guard's rubbing. Maybe there's a belt or a band that's out of track. So there's a lot of great things that you can do airborne wise for mechanical as well, especially when you deal with coal power stations. You got miles and miles of conveyors that bring the coal up to the burner. So, the old test method of having to make contact on it would take forever. So being able to use the airborne module to walk the line, or in some cases jump in a Kubota, and you got the driver operating the Kubota, and you got the inspector holding the ultrasound gun out the side of the Kubota, listening to the conveyor rolls, and I hear something, let's stop, get out, investigate, mark it, hang it, tag it, move on. So it can really quickly do stuff. On electrical side, that's where ultrasound really takes off because it is not really voltage dependent. And we can do partial discharges in oil filled transformers by using a contact module. We can hear what's going on inside of that very quickly. One of the things that these transformers are subjected to is air ingress, and air ingress can cause bubbles, and those bubbles
Mhm.
become uninsulative. And now you
Yep.
get these little bursts in the bubbles, or as the deterioration from heating components inside breaks down, it can also build up gases that are conductive to electrical current. So you hear these little zaps and pops in there, which is not good on a large
No, definitely not. You get
transformer.
your treeing implications and everything else, and the degradation of the transformer is
Yes.
can
So, I
often be
mean,
catastrophic. So definitely important.
yeah. So electrical inspection, whether it's contact, and let me emphasize this, on exterior surfaces, never make contact on energized gear. Back to mechanical. If you can't see in the hole, don't stick your contact module in the hole. I have to put that out there because these are experiences that I've seen on LinkedIn or personally had with students that tried to do these things. So got to put a little bit of safety in there. But you get into, building envelope testing with that flat pitch roof. You can also put in a, what's called a tone generator inside a building, and then you turn this thing on, it produces high frequency sound again that the device will hear, and you can try to pinpoint on the roof with this thing inside where's the sound entering, because a lot of times it's a tortuous path coming down an I-beam and dropping 30 feet away from where
Wow.
the actual leak is. So there's a lot of cool things we can do on the building envelope side, even for your home windows. Winter's coming up and you've got draftiness. Well, you put a tone generator inside the house, you go outside with the ultrasound, you scan around, you bring in the IR on top of that, like I did when I was a lieutenant with the fire department. Could see my cold spots in the middle of winter. And inside, I
That's
put the
wild.
tone generator. I could caulk up outside where the smaller spacing was, and then go back a couple days later and see the complete thermal pattern difference by using the two technologies for building envelope. It was a win-win for me because it saved me, I think, $400 that year in oil I didn't have to buy because it reduced the drafts that were coming in. So there's a
Absolutely.
lot of cool things we can do with ultrasound, but there's things out there that we don't even realize are making sound. And we like to say that you have frictional occurrences, you have turbulent occurrences, you have impact, you have man-made sounds from ultrasonic motion detectors are one of the biggest ones that produce high frequency sound. Ultrasonic security systems are another one. TVs, computers, there's all these sounds that we can hear at 40 kilohertz when we're using airborne modules that we wouldn't know if we didn't have this device. And I
Absolutely.
actually sent the State Department when the Cuban incident happened with the embassy, because I'd worked at the U.S. Embassy in Berlin in 2009, and they had ultrasonic motion detectors and security systems in there that when we were doing our training on the ultrasound, what is that noise? You start looking at the ceiling. Oh, look, there's the emitter, and on the other side of the little disc, there's the receiver. And those ultrasonic motion detectors were kicking out 105 decibels. And that pressure wave, believe it or not, can affect the human body. And I believe a
Really?
lot of these buildings that claim they have sick building syndrome, it's not because of mold. In some cases it is mold or biological growth. Let me not put that word out there because mold's a bad word. But biological growth or environmental risk to atmosphere. A lot of times it's the monitors that people are standing in front of. A lot of times it's that motion detector or that security system that's producing so much noise that the body physically can't translate it, and that pressure wave still affects the ear.
Wow.
Underground leaks are another thing ultrasound can be used for. And again, you pair that up with infrared and you can see the saturated area in the ground, especially if you're using a drone. So you fly the drone, say, hey, I've got a 30-foot hot spot in the ground in the middle of winter. I know I've got a steam leak going on somewhere. Let's pinpoint now with the ultrasound. We know where the pipe run is, and we can drive rods in the ground and listen and get within a foot of where the actual leak is. So you don't have to dig up a 30-foot long trench.
Right.
Maybe you've only got to dig up 10 foot. So little things like that are great. Obviously, let's go to trenching protection. Just mention that. Please, if you're digging, make sure you have your
Don't get in
walls up.
trouble with OSHA.
Yeah, I don't want to be telling people to do stuff without trenching safety requirements. So there's a lot of things we can do. We used it on the hazmat team for ammonia rail car simulation. We had the smoke generator going, and we had a parabolic dish, and we're 300 feet out, and we could clearly hear outside of the hot zone which rail car was leaking. We could also hear the Amtrak
Wow.
train next to it with the brakes popping off as well too. So there's a lot of cool applications. Transportation's another one. New York State Police Department, their DOT division, they actually bought some of the old UE 100s back in the day to do leak detection on the truck's braking system. rather than doing the soapy water. Although soapy water does work for emphasizing the point that this technology works, it's a lot faster to get on that little cart instead of spraying everything, wait for bubbles to develop, just to go along and listen for a hiss. So I get geeked up pretty easily about this stuff. I don't know if I'm taking down a tangent road here, but
No, I think it's very good. You're covering all the versatility of the technology is very important, right? So obviously we're a very power centric organization. That's what we recruit to and everything else. But I think you definitely did a great job in highlighting the versatility, like we mentioned, and the applicability across the various industries that are out there. And I think that is a great, amazing plug for both technologies. And I always found it, interesting to me, like because the sound side of it, from like I was an anti-submarine warfare officer.
yeah,
We're using a macro size in our active or the passive side where we're just listening with the various hydrophone modules that are out there to kind of get it in the distances that we can see without getting into classified. We have SOTAS arrays out there that are just these gigantic miles out into the ocean, and as part of our overarching defense infrastructure there, so where we can hear subs coming across the Atlantic or the Pacific well before they're even in range of doing any damage. And the same thing applies on the obviously the thermography. 25 Mike comes to mind for me, where we had the remote IR capabilities there, and I remember that old grayscale that you pointed out is just wild. And then just to see how far the technology has come. Now you have these, FLIR modules you can plug into the bottom of a phone that'll give you a full blown color perspective. So truly fascinating technology. And I think you did a great job of covering all the various assets and industries that you can go in and leverage the training that you get if you are a veteran that decides to come in and take that free training. And can you do a little bit deeper dive into the Veteran Assistance Program and kind of what that looks like? What is the curriculum about? What is the placement rate on the backside? Where do you typically see those folks land?
yeah. So as far as the program goes, once you're done with it, it's 32 hours basically that you need to set aside. Just go at your own pace. There's lectures and then there's quizzes. But one company we're working with quite often, prior to the VAP, they had sent us 32 students the year before when it was a discounted rate for veterans. This year, they've doubled that number. And they're
Wow.
hiring predominantly veterans. So anybody out there that's an electrical landscape, I'm going to give a plug for DLB Associates because they're definitely one of the top users of our certification training. Every request that comes in says it's required for my job as an electrical commissioner with DLB Associates. So they've really honed in on this is the best way to deliver the training that our team needs, because these people aren't in an office, they're remote.
Right.
And, being able to do it online, yes, you don't get all that hands-on that you would with a live class. But as you mentioned, you can go online and get one of these little FLIRs.
There you go.
Just very inexpensive. And the quality of the image is so much better than what they had in the movie Predator when they were using the nitrogen cooled IR camera out there in the jungle. So, the technology's come a long way. The price point is unbelievable. You can pick some of these up. There's a company called Hike Micro. There's Seek Thermal. There's Fluke. Like all the IR companies now have these small ones that you plug in. The one we like to use with the tablet with our ultrasound sensor, you can just plug it in, Bluetooth enabled, clips right on there. It's a FLIR Edge 1 Pro. These technologies and that it's so great. But being able to, as a student, to learn how to use this. And if they buy one of these cameras on their own for the course, that definitely helps them kind of understand the lessons that were given during the course. But as far as placement, we're seeing 100% with the DLB personnel. And the vets, the drone guys and gals that are coming through, and the drone launch guys and gals that are coming through, again, they're taking it and instantaneously, they're taking their business to another level because now they're adding another service that they can provide. One of the drone operators up in Ohio just started working with the Fish and Game up there to do deer census. Because it
makes sense. They're going to put off a heat signature, so you're definitely going to be able to see them, and if you can do it, absolutely.
So you can far more accurately determine the population of deer in a community by flying drones in the middle of the night. It's not as invasive. You're not looking for visual indications, with your eye and a spotlight, which, most of the time, if you're spotlighting deer, that's another issue that we.
I can neither confirm or deny that was part of my existence as a young man growing up in Texas.
Yeah. So, I mean, this whole thing just ties in so well that they're coming out with a skill set that is now almost instantaneously deployable, especially in the drone landscape. Like I said, building an envelope testing for flat pitch roofs, that's an instantaneous return on investment. And the investment's free other than the drone platform, the IR camera. And that's already a big costing for a lot of these veterans coming out to have to look at $35,000 potentially to invest in a DJI drone or one of the other drone companies. And DJI, just for those of you that may be looking at drones, keep in mind that there is a lot of pushback now on Chinese made companies, or being able to test infrastructure with DJI. That's been one of the things that the gals at Vets Drone kind of run in on some of the contracts is it's been specified by the Department of Defense can't have a DJI.
No DJIs. Yep.
When our guys,
they haven't gone full ban, but I've seen that there's definitely been talks of banning all of the, specifically the DJI drone seems to be the one that's pointed out most often. But yeah, I'm definitely seeing that. And what are some of the other providers of drones out there? Are there any American-made drone companies that you know of? I know it's kind of outside the wheelhouse.
As far as the drone landscape, I'm really only familiar with the DJI because that's the predominant one. Anytime that
they are,
I've been at these lectures, the personnel come through here for a little hands-on. They're predominantly that's the front runner. They've been doing it the longest. They have the biggest payload capabilities. So I mean, we've got a FLIR one that we have sent over the Middle East. But again, there's requirements over there. Our personnel have to be licensed with the government, not just their pilot's license for what their version of FAA 107 is, but they actually have to be registered government operators over in the Middle East. So there's requirements as you go around globally as well too. So I don't want anybody to think that you can just take your drone overseas because more than likely they're probably going to get confiscated if you don't have proper licensing and authorization to use it. But as far as drone companies, there's a lot of them out there that I'm unaware of because generally I'm camera and ultrasound
Right.
So.
I didn't know. I figured you might have some insights to offer there, and that is one. But like you said, to your point, I've definitely seen a lot of the literature coming out with regards to the bans, the DJI drones, and but I'm sure something will step up, kind of fill that void. And I know there are other like you. I know there are other manufacturers out there. It's just I wonder how many are not Chinese manufactured at this point. So.
Well, and you can get away with a lot when you assemble here in the U.S. The parts are coming in from elsewhere. So that's the other way that these companies are trying to get around it is they're now setting up warehouses, quote unquote, or factory assembly areas on U.S. soil so that they can say, look, it was assembled here, so it's not completely owned by China.
Right. Where there's a will, there's a way, Drew.
Yes, there is.
That is awesome. And I think we hit on all the salient points. Like you said, the employment opportunities on the backside are fantastic. And the money savings just by going through the program. Obviously, if it's free, it doesn't cost them anything. With regards to the curriculum itself, so it's obviously an online platform. I'm assuming there's a learning management system that's kind of instructor-led. Can you kind of take us through the media aspects of the training program? Like, how was that broken down, and what does that process look like for the individuals going through the program?
Yeah, absolutely. So we currently switched over to an LMS, learning management software called the Chevo. And we had our previous iteration we rolled it out in 2019, luckily enough, before COVID. So we had some experiences. The customer feedback was not always the best because we had to lock out the ability to fast forward. And that in turn locked out the rewind and it didn't have the stop. Remember, like we all know how frustrating it is when you're doing your streaming thing and you go back into pick up where you left off and Netflix doesn't remember where you left off or Amazon Prime doesn't remember where you left off. And you're like, we already watched this.
Yeah.
Well, with the new Chevo, you can enter into the platform. So the first step is you get your enrollment package, you download the digital book. We're trying to, part of our green initiative is to reduce carbon footprint and, consumption of consumables. So we've gone to a digital book format, which is great because now if you got a tablet out in the field, you can refer to your book in the field as well, rather than bringing out this hardbound book or, the spiral rule. But So the first step, download book. Then you take module 1. And then after that module, there's a 5-question quiz. And some of the questions are directly taken from the book. So that's how we ensure that not only are they watching the videos, but they're actually reading the corresponding chapter that relates to that in the book. Because that was one of the things we had to kind of put into place, since we don't have that hands-on interaction back and forth with the students live. We have to ensure that that additional content that we tried to trim out of the videos to make them not so long can be picked up in the reading material, because there's different ways of learning. I'm definitely a hands-on guy and a visual guy. So I like videos. Give me a video all day long and then let me do some hands-on. There's people that are strictly lecture learners. There's people that are strictly book learners. There's combinations thereof. So we try to make sure that we have all modalities covered with it. Now, as you progress through, you hit a segment quiz, and there's 20 questions. Those 20 questions kind of help build your knowledge for what you should expect to experience in the final exam. The level 1 is 17 modules. So if you set about 17 to 16 hours of visual time online, watching the lecture, you can stop it, walk away, come back to it, whatever the case may be. We generally say you need to try to complete it within a year. We've got some flexibility. If we just had somebody today, he started the course last year, had a medical issue. He's just now getting back to work, sending the email today saying, hey, last year I started this. Can you help me out now? Yeah, you're still active in the class. We'll send you a reset.
Awesome.
But once you get past the module quizzes and all the modules and the 4 segment quizzes, then you're set for the final exam. The final exam is 80 questions. It's a 2-hour time limit. So most of the time it takes on average about 48 minutes. The ones that struggle are generally the ones that are trying to go back into the book to find everything. So trust your gut, go with your gut. Don't second guess yourself. But average is 48 minutes to complete the quiz or the final exam. You need a 70% on that. You need 80 during the week or during the modules. So combined is 75.
Gotcha.
And as far as the rate goes, if you fail the final exam below a 70, you have 1 attempt to take it again, and then you're paused for 30 days.
Okay.
If you fail it a third time, then it's a 6-month pause.
Gotcha.
But trust me, the exam is not that hard. I'm one of the worst people when it comes to taking tests. I get my anxiety ramps up. I second guess myself. I doubt myself, and go back a couple times and circle back through. Well, was that one? We wrote the test not to be different than the material that was covered in the course, because that's one of the other things I hate is when you go through these lectures and you read the book and then the question is worded completely different to try to throw you off and make you think deeper, which, okay, I get that, but this isn't a PhD engineering degree. We don't want anybody to fail, but we also want to hold them accountable. So our success rate is about 98% passed.
Wow. Good.
And that's because, Paul and I worked really hard to make sure that we didn't have any gotcha questions in there either. There's straightforward question and answer, test your knowledge. We don't have any mathematical equations you have to get a calculator out to figure out. So it's a pretty straightforward final exam. And again, with 98% worldwide completion and success rate, I'm pretty happy with that.
That's impressive. Yeah, very impressive. And I want to dive a little bit deeper. So obviously with us being a primary electrical, I know there's a report function. So seen several of the NETA folks that are out there doing a lot of the thermography testing, and I've seen how they incorporate it into their test reports. Do y'all touch on that in the curriculum as well, and kind of the advantages, disadvantages, and things of that nature with regards to the electrical side?
Yeah, so absolutely. We interact in that landscape with NETA. We are actually a NETA accredited trainer. So if the company that they're working for is NETA accredited themselves, they can take the certificate and apply on NETA for NETA CEUs. So that's one of the things, but your company has to be NETA approved and accredited. So that's a good thing. We also work with the NAC guidelines, but the big one that we really follow and try to push in addition to ISO is NFPA 70B.
Huge for everybody. That had such an impact on the power industry specifically, and we're seeing a lot more. And I think it's definitely needed when you're dealing with IDLH, right? Immediately dangerous to life and health. It's very important stuff. So safety is not one to be messed with when you're dealing with the voltage levels and amperage and everything else that we're dealing with. So couldn't agree with you more.
And that's where, the windows come into play, because, if you look at new guidelines, the biggest change was you now shall, not should, shall have an electrical maintenance program. you shall have certified personnel. So whether you're using high pot testing, motor current analysis, infrared, ultrasound, whatever you're using, you have to be certified and it has to be documented. And it actually breaks out what you need to use infrared on. And it recommends partial discharge testing. It recommends acoustic emission testing, which is ultrasound. I hate that term acoustic emissions because for me, acoustic testing by AS&T is the audio condition of the human experience, or a microphone meter where you measure decibel output. So acoustic emissions is one of my bane of existence. But
No, fair
anyway,
enough.
those guidelines and being able to keep that fixed and guarded position with infrared windows and ultrasound ports and not having to put on an arc fire suit, because I've got mine over my shoulder here and it's just as bad as my turnout gear in the fire department. It's just as bad as the mock
Absolutely.
gear we wore during Desert Storm. It's cumbersome. You can only do it for so long before you got to get out of it and take a break. And it just slows down the process. Whereas infrared being done with infrared windows, it's literally as you're dressed in a level 1, open the hatch, scan. If you got ultrasound, plug in the port, listen, and you move on. So you get fixed, repeatable test points. So there's just so many good things about the NFPA 70B now mandating shall have an electrical maintenance program, shall have trained and certified personnel. And that certification, that ISO 18436, is a known standard. So heaven forbid there's ever, any catastrophic accident at a site, there's documentation that, look, we had this program in place. All of our personnel are trained to ISO 18436, Part 7 infrared and Part 8 ultrasound. And we've got our units are calibrated annually. So we've done everything we can on this end. We didn't have any indications. And as you know, electrical, when it wants to go, it's going to go. So,
And go you typically in grandiose fashion as well. If you're
yeah,
if you're out on a substation, it's like one of those little things I probably shouldn't admit publicly here, but like the watching the Jacob's ladders as they're climbing in the air and the monstrous explosions. I may have dive down that rabbit hole a little too many times on the YouTube machine there, but it is definitely wild. And just to watch, like we talked to earlier, the technology just seems to be constantly evolving in the space. Is that something you guys kind of keep an eye on, as well as like what's new in the market, or to kind of pulse and update your training, or do you have like a time period or frequency with which you guys are reevaluating your course curriculum to make sure it's up to date with the latest technologies?
Yeah, so as any updates come out with ISO 18436, Part 7 and Part 8, we'll always look to address. We have an annual review cycle. So January to February, we spend 2 months reviewing our content in our infrared 1. Then March to April, we do our level 1 ultrasound. And then every 2 months, we're diving into our certification material, see if there's been any changes. We also look at the standards changes. And as far as technology changes, the biggest thing that's changed in the last 3 years is the ultrasound game. Ultrasound historically had always used piezoelectric crystals as the primary focus of being able to detect those pressure waves and then give a voltage and then give a decibel value relative to the intensity of the anomaly. Now we're seeing more and more of these visual sensors. So in this is our Sonus Viz, which we're going to be launching here very, very soon. There's MEMS arrays, and they're electronic microphones, basically. So this one has 3 arrays of 8 MEMS sensors that can find the turbulence from the leak. Wow. And it can also find electrical anomalies. And it's also going to be used for steam trap or for steam system leaks and determining the loss in atmospheric release of steam. So it's not going to do internal at this point. It'll just be external. So all those things calculate really quickly with these MEMS arrays, and we can actually generate, hey, this nitrogen gas leak is costing you X amount of dollars annually, so your cost avoidance is this. On the steam system, it'll be the same thing. On the electrical, it's, hey, it's corona, it's treating, it's tracking, it's arcing, it's loose connections, it's dirty power. So all these new technologies are kind of pushing to a digital landscape, getting away from the piezo crystal that have been used since the 70s. So
wow, that's impressive.
So to me, that's the great thing, because now you got that digital signal, and having a tablet out in the field is way easier than having some of these other handheld devices I've held over the years that they're cumbersome and they're not tied into a cloud-based system. So you're reporting, you're still recording and downloading to a computer. Well, now with tablet-based, you're sending it right to the cloud. So you got all your reports instantaneously going back to a cloud-based software that if you were my manager, I could be out in the field and say, hey, Micah, take a look at this one. You can pull it up and be like, wow,
That is
$3,500 a
awesome.
year in compressed air loss. That's pretty significant. Let's put the work order in now, right in the cloud-based system. Then I can take the tablet back out, document it, and complete the work order with the same tablet I found it with. So that's the solution for me. Is that's been the missing piece, whether it's been infrared or ultrasound, is getting that data from the device back to the software and to a manageable platform that everybody can access. And everybody, Amazon was one of the biggest ones. They're like, we want a centralized system, but we didn't have that with my last company. We couldn't do that. The software had to be installed locally, and then they had to send the reports out. So nobody could look from the corporate office at Amazon in Nashville and see how they're doing. They literally had to wait for the reports to come in. So now with cloud-based, that's the win for everybody, especially when it comes to electrical,
Absolutely.
to be able to instantaneously take that data, send it up to the cloud, and alert somebody that, hey, we need something done right away. Let's get this taken care of. Let's schedule some downtime. Let's inspect this. Let's bring out the high pot testing. Let's bring out the mega. Let's bring out the infrared. Let's get another technology to confirm what's going on. Let's check the dissolved gas report, see what they had. It just allows you to do things more efficiently.
And to me, and so I'm gonna kind of shift gears into maintenance. So obviously in the past we had O&M, operations and maintenance, and then preventative maintenance was a major push, but now I'm hearing a lot more with regards to predictive maintenance. And this seems like a technology that is highly valuable for predicting failures instead of just doing it on a period, on a certain periodicity, be it monthly, weekly, semi-annually, annually. Does that kind of echo what you're seeing out in the field with regards to the predictive versus preventative maintenance aspects?
Yeah. So as PM, as you mentioned, preventive maintenance, anybody that's serving the military knows, and especially the Army, every Monday was motor pool time. You checked your fluids, and it always cracked me up on our FISV that, hey, we check the oil every Monday, but we only replace the oil when it gets to a certain level. But we're taking, this 1 ounce, 2 ounce sample out every week. Why is the oil getting low? Track hasn't moved in a month. But anyways, so PM, preventive maintenance, you're always going to have some level of preventative maintenance. That's on your less critical assets. This technology, when I first started, was the predictive end. We're actually going out based off the time base once a month to test our motors, annually to test electrical, whatever the case was. You went out on that time base to detect and predict what was happening. Now with the technologies being integrated and having the IoT capability or cloud-based software, we like to call it more condition-based maintenance and repair. Because now you're taking, based off the information you get from your ultrasound, taking the information you get from your vibration, your infrared, you're doing a condition-based maintenance rather than monthly, because one of the problems we have is human interaction. You've probably been to the site where they're like, well, we don't want to shut it down because we don't know if it's going to start back up. The Mars lunar rover, the first one they sent up, was designed for 90 days. And I can't remember the name of it. Sorry, my TBI is kicking in. But, we used it as a reference that it was built for a 90-day mission. And it lasted 14 years because nobody was turning wrenches on the damn thing. Right? The only thing that stopped it was the accumulation of dust on the solar panels. That was the last thing. And there's a great documentary about it. It's actually pretty impressive to watch and, see the people get emotional about, hey, this device we built lasted for 14 years. How many millions of miles away?
Right. Impressive
Nobody
stuff.
touched it. There was no PM. There was no predictive on it. It was built to run. And a lot of times that's what happens when we start taking stuff down on a time-based method. We can actually induce the failure at startup. So having a condition-based maintenance program and repair program using all these technologies integrated will help to reduce that. And you're more critical the equipment, the more frequent the testing should be. And this always
Makes sense. Yes.
This gets into one of my banes of existence in the industry. The most important assets on any site is the electrical assets. So why are they annual, but I'm going to go test that 1700 RPM conveyor motor once a month?
Right. You can't run that motor unless your electrical squared away. So
now having windows and ports and these technologies, it makes it easier to do because now you can do it more frequently on your critical assets. Again, criticality ranking is something that a lot of companies will do. Your pinch points and your pain points, what your most critical gear is. Those should have the most frequent testing. That's where these predictive technologies should be used to do that condition-based maintenance and repair recommendations, because you're collecting all this information on temperature and decibel levels and the vibration, and you're just using that data as a doctor does. I just went to the VA yesterday. That, thanks for rescheduling, by the way.
No worries.
Because they're getting ready to do some more surgery. But to get to that process, it's been MRIs, it's been CAT scans, it's been X-rays, it's been physical therapy, it's been all these different modalities to try to diagnose and predict and forecast what's next for me. Well, if we take that much time and effort for human bodies, we should be doing that same thing, because we use the term asset health.
Right.
So we should be thinking of ourselves when we're in this landscape that, hey, look, we want to do all the diagnostics that we can. We need to do ultrasound. We need to do infrared. We need to do motor current. We need to do mega testing. We need to do everything we can do to make the correct diagnosis. So when we go to management and production and say, we need to take this offline overnight because we need to do a repair, especially on oil field transformers with an 18 to 24 month lead time right now. And now we've got this strike at the ports going on. Mm-hmm. Oh goodness, that's just going to make things.
It is definitely, and I'm some of these lead times based on my conversation with Drew Welton. We're talking 5-6 years in some of these cases of the GSUs. If you're using a provider outside of like China, for some of that stuff, and it is insane. So if one of those goes, you're going to have some substantial impacts to your operational capability for
Absolutely.
Sure.
And that's all the more reason why we need to be using these predictive technologies and a condition-based maintenance model to maintain these, because we're going to get the earliest indications with these technologies that something is starting to occur, and Absolutely. We can be prepared for it. A lot of these assets, like the last site that I was just at with Josh Robinson up in Indiana, I'm not going to say the name of the company, but the assets were almost as old as I was. And I'm going to be 55 next year. The average lifetime they're designed for is 25 to 30 years. Right. So you're already 20 years beyond expected life cycle, which is great because they did build things better back then.
I would agree with that statement.
But we're reaching a point now where they literally just last week after we left, and it wasn't one of the assets we had tested, they had a catastrophic failure. And now they're like, hey, can you guys come back and, since our guys are just starting off with this, can you actually do the service for us with infrared partial discharge and ultrasound? I'm like, yeah, we can. Just let us know when you want us there. Because now they're realizing that, shoot, we got into this too late. We just got some guys trained for 2 days. They didn't get any certification. They just got a equipment orientation, software orientation, a basic introduction to analysis. And they've got an end of life that's coming up. They had to rob Peter to pay Paul. They had to take one of their transformers from one of their sister sites to supplement this. So it's at that point where companies need to really start looking at how are they going to maintain what they have, because it's going to be harder to get new replacements. So
couldn't agree with you more on that aspect. And I'm shifting gears again here. So we've mentioned ports a couple times. Can you kind of talk through? I know that's one of the things that IRIS is known for, are your inspection ports. Can you tell us what does a port consist of? Where you typically find them? Obviously, it's a safety issue, right? To have the ports so you can actually go in and do that. But I'm just kind of curious, and it kind of goes through my mind, so I'm asking the layman's questions. But whereabouts would you have these ports placed? Like you wouldn't put them on a transformer, I'm assuming. But what are those ports used for, I guess, is the blanket question.
Okay, so the ultrasound ports, what they are, there's two. There's an airborne one, which can work with any of the visual cameras, the acoustic cameras, because it gives you direct opening in the panel. And it can be a standalone, or it can be embedded in one of the infrared windows. So we have a little hatch cover for that little smaller grill area for the air. You can't put a finger through it. The grill is pretty small. But on the plug-in side, we have VPDSs, and there's basically what you're doing is you're taking an 1.5 inch punch out, you're knocking it out, and you're embedding a piezoelectric crystal transducer inside the cabinet.
Gotcha.
So as long as it's not an oil field transformer, right, you can put it in any of your dry assets. But then we've got cabling for STT, we've got cabling for Sonatech, we've got cabling for UV systems, CTRL. Basically any of the PD detectors, EA, HVPD, Sonus or IPEC, and then our private label devices will all work with this. So it basically takes your transducer from your device, and it's like you're sitting inside the cabinet now.
Gotcha.
And with the reflection of sound, it will reflect into that. It has about a 165-degree field of listening coming off it, and that metal is going to bounce that sound wave. One of the problems we've historically had when I used to do electrical inspections with my last company, UE, is when you scan, you had to go around all 4 seams. And those seams are next to other cabinets. So if you heard something, well, is it coming from this one or is it coming from this one? By having the sensor embedded, we avoid what's called diffraction of signal. And the best way I like to talk about diffraction of signal is, you ever been to a concert hall, Michael, with the doors that close?
I have.
Okay, you step out for a smoke, a beer, or whatever, and you go back in because the show's going. You open up the door, and suddenly you're just blasted with all this sound coming through that door. And when you step through, it drops. Well, sound funnels out in a diffractionary method, and it intensifies as it goes through that small area. So it's a lot like a garden hose. When you put your finger over it, suddenly it starts spraying everywhere with more intensity. You can wash down the driveway better, right? Sound is the same way. That pressure wave being funneled through will increase the decibel value. So that's always been a problem with electrical inspections. We haven't been able to trend that decibel value historically, because the diffraction is actually increasing what the decibels are that would be occurring inside. It sounds louder on the outside. Plus, different statures of inspectors, height, size, build, your angle. I might mark it with a little grease pencil on the cabinet, say, hey, date 8/24 or whatever. And next month you go out there and your angle is a little bit different. You might see a drop or an increase as well, because your angle of approach to that seam is different than the one I took. So again, that's another problem. So these ports solve that. I like to call it a fixed repeatable test point.
Makes
because
sense.
You've just got a single port that you're walking up. You take your cable, connect it to your device that you have from whichever company, and you plug in a headphone jack, and your device sends that 420 millivolt signal up to the piezo, and it receives the pressure wave and gives you feedback on what the decibels are.
Gotcha.
So now you can trend.
Absolutely.
You've got that fixed repeatable test point. You're taking out the human interaction of angle of approach. You're taking out the diffractionary signal. You're also taking out any background noise, or what I like to call antagonistic ultrasound, from ballast or motion detectors or bugs or conveyors or whatever's around you that's producing ultrasound. So that is a win for me. Like when I came to interview with Martin and he showed me that, I'm like, oh my gosh, that would save so much time instead of scanning all 4 seams on every
right. And like you said, to knock out a lot of the noise that's associated with the varying angles and everything else, and the surrounding sound from environmental noise, I guess you would call it. So that is some very, very cool technology. Are you seeing more implementation these days, or how long has that technology been around, and how much more implementation are we seeing in the industry for these ports?
Well, again, since 2023 with the change to NFPA 70B, our business has seen a great uptick. I mean, we've been steadily growing since 97 at a consistent rate that Martin has been very happy with. Every year he sets down what his goals are for the company to grow, and it's been moving beyond what he's expected every year.
Outstanding.
The VPDS integration is now starting to take off as well too, because the word's getting out that this works with any device.
Right.
We have cables, like I said, for every major ultrasound brand, every major partial discharge testing brand. We can work with just about anybody's gear.
That is impressive.
And that saves so much time because, again, it cuts down not having to scan 4 sides, and it gives you that one test point that hey, I'm walking up here, take my value, and now I can trend. So that's really why we're starting to see that integration come up. And now the airborne ports are starting to circle back because more companies are going to the acoustic cameras. So to be able to do electrical inspection with the acoustic camera is kind of like when I went through my first divorce and the judge is like, Mr. Waltz, I hear what you're saying, but show me where this happened.
Right.
People don't believe what they hear initially. Like, I hear something going on in that cabinet, but I'm not sure. Well, now you take an acoustic camera, you get that heat map, or you get the circle targeting where the sound's coming from. And some of them will even tell you, hey, you have corona, you have tracking, you have treeing, you have arcing. So that's where the progression of these technologies and the ports definitely go hand in hand, because again, it's keeping that fixed and guarded position. You're not having to de-energize to take a panel off and then gear up to stand there with any ultrasound gear or IR to do the inspection. So you're maintaining that barrier at all times. So you don't have to worry about that. So that's why we're seeing a progression of success with these devices, because more and more people understand that, hey, I might not have ultrasound right now, but I know based off NFPA, they're
You're going
saying
to have to.
you're going to have to.
Right.
We want to anticipate that. And for a company to do it to a window, it's not that much of an adder. Like the sales team can tell you, I think it's like $75 to put one of those little
Really?
ports into a window.
Gotcha.
The newest realm that, I'm kind of getting ahead of my skis a little bit, but our IoT department is building IoT sensors for temperature and humidity. We've had iterations. We're on the second iteration that we're going to launch, much smaller package. But the next progression will get into, beyond temperature and humidity, we'll get into sound. It'll get into light. It'll get into vibration. It'll get into IR. So we're going to have these little, I call them honeycombs because they're shaped like the Iris logo, 6-sided. So you'll be able to have these little ports on there with a 5-year battery life that sends out a signal. So if something happens and Micah, it sends you the report, you can say, hey, Drew, I need you to go out to MCC 1234. We had a spike in temperature and humidity, and there's ultrasound condition, and there seems to be a IR image, thermal pattern showing up when I look at it remotely. Can you go out and take a look at it more in depth? Now I go out with ultrasound and infrared, and I can get a deeper dive onto it. So it gives you that heads up, kind of for the future lockdowns. If there's, heaven forbid, we ever have another scamdemic or plandemic or whatever you want to call it. Let me put my tin hat away here. But we can get out there ahead of time because we're also looking at staff shortages.
Yeah.
The gray tsunami is a real thing. We've got a lot of experts that are retiring and we don't have replacements for them.
Absolutely.
And suddenly,
See it all the time.
Yeah,
it's crazy.
Now you're asking a technician that's never used this technology to fill in for the guy that's been doing it for 30 years there. And they don't have the schooling, but they still, want to get the same details they used to get from the other guy. So we had that void. So these IoT devices would be able to supplement that workforce until their skill level gets to a point. We got service companies that are really chomping at the bit for this too, because it would save them having to drive their personnel out. They'll charge, they'll do a SaaS model, software as a service, where they're monitoring and they'll send the reports to the client saying, hey, this one's going out. Do you want us to come out? And then they'll do the site visit. So they can supplement and they can keep their workforce more diversified because now they don't have to be babysitting that asset every month or every 6 months or annually. They can use that IoT solution to be there on site.
Can you tell everybody what IoT stands for? I know we're acronym heavy, and I know, but we just want to make sure because we threw out some, and everybody's probably scratching their heads a little bit.
Yeah, so Internet of all things.
Yes.
So these are generally cloud-based software platforms and monitoring systems that all tie back to a cloud that can test many different ranges of things and give you conditions remotely. Like some of these remote hydro stations up in Canada, they're really chomping at the bit for this because I've had to go from New Liskeard, Canada, drive 2 hours north to get out to this remote hydro station, test for a 10-hour day, and then drive 2 hours back. Well, if they have IoT up there, then that IoT can do that, and you don't have to send that personnel 2 hours via car up to test it. You only send them when something's starting to trigger. So that's kind of what Internet of all things will do for society. Smart homes, there's another IoT solution. So you're using the internet to determine, hey, my garage door is open. I need to close it. Hey, my security system's going off. I got a water alarm. Hey, let's turn on the camera, see what's going on. That's the Internet of all things, using the internet as a bridge between having to physically be somewhere and see the condition, what's going on.
We could probably summate it and just call it remote monitoring as well. So you have the ability to do real-time remote monitoring, which is hugely impactful if you think about it, for monitoring throughput faults on relay protective schemes and everything else. It's just that's what we're seeing that's trending now, is a lot more of the real-time remote monitoring that's going to give you more of that predictive analysis that you can use to implement into your maintenance cycles and things like that. And then when required, you get a technician on site to do the additional levels of granularity required to isolate. So truly impressive stuff. And like I said, we're seeing more and more of it as things progress. Had a conversations all the time, right? But through fault monitoring with Drew Walton on that perspective and how they're actually able to do that remotely now more so And again, to your point of predictive maintenance is more really what we're seeing that used for in order to schedule stuff out. So
Yeah.
truly fantastic technology. And we're right at an hour here. So it's definitely been informative. Want to get kind of closing up, but so for everybody out there that is a veteran looking to get into the space, this is obviously worth the time and effort if you want to stay in power. There's a lot of parallels between, as Drew mentioned, the NETA testing aspects and now being folded in there. I know Michael Labite, somebody who I enjoy kind of following the content on LinkedIn, and you're always seeing him taking, IR images of pole mount transformers and things like that. And you can see the bush, the tap failures and things like that. This technology is not going away. It's only making the industry better. And this is an opportunity for everybody to get out there and, become a part of the industry and really, add another tool to your tool belt, be it the ultrasound testing or the thermography testing side of it. So truly, truly impactful stuff. And it's just phenomenal. Obviously, you're a very veteran-centric organization over at IRIS. And I think what you guys are doing is phenomenal. And so for folks that are interested, where can they go and find how to sign up? Where do they need to go? Do they just need to go to the IRIS website? I know the answer to this for the VAT side, but can you kind of walk the audience through that?
Yeah, sure. So iris.com is our main landing page. And at the top, you'll see a banner that says training. And when you hover over it, it'll say SMART training, which stands for safety, maintenance, and reliability technology. And below that, it'll say veterans program. You click on the veterans program, and that'll take you to our training page, the SMART Institute training page. And you can enroll and request a course, either one infrared certification or one ultrasound course. From there, if you want to load a certificate from boot camp or basic training, we don't want your DD-214 with all your information. If you do send that in there, then just redact it, please. I know we're working. That should be ready to go here by the end of the week, which will be tomorrow. But it just needs some form of verification because we're getting so many in now. I can't take the time to call everybody like I was. And kind of like this conversation, I end up having an hour-long conversation with somebody about their time in service and what they did, just out of curiosity and building that brotherhood up and sisterhood. Right. So we're trying to get more automated so it's automatically enrolling and the students don't have to wait for us or Paul Goodbody to verify their time in service.
And so you guys aren't leveraging like the ID.me or anything like that yet?
We tried that. They told us that because the course was free, it wouldn't be viable for us. So they would never tell me what the costing was a month, but because we're providing the training for free to veterans.
Gotcha. Like, it would just be a cost center for you at that point. Okay, makes sense. No, absolutely. No, again, thank you. Like I said, this is one of those things that I always see as kind of a parallel in the industry. And I know it serves its values. It was an eye-opening conversation to me. I know this is conversation number 2 for us on this topic. And like I said, it is awesome stuff. A free service to veterans getting out. So I would highly encourage everyone. And IRIS is IRISS, not IRIS like the I. So IRISS.com, and you'll see it up there at the top of the banners, as Drew mentioned prior. Well, any last minute insights or parting thoughts that you would like to share with the audience here?
No, I'm just if you need to get in touch with me as well, I'm on LinkedIn. I do post pretty regularly. I don't like to do a lot of salesy stuff, so I do a lot of technical information on there. My last post on the graphic of PF curve of an oil field transformer has really taken off. I think yesterday it was up to 20,000 views and 180 reposts. So I'm kind of like, okay, that's cool. And then some random company out of Australia gave me props as a pioneer. So I'm like, oh wait,
thanks guys, appreciate it.
What?
It is awesome. We get some similarities here, like in some of that stuff. I think it was Cargill gave us a shout out and some other stuff, and I love it, man. And I think we need more content like this out there, right? More of the technical stuff, because to your point, the gray tsunami is not going away. We have to encourage more individuals to get into this space. And from a monetary aspect, like, man, you can make a really good living doing thermography, doing ultrasound, doing NETA. all these blue, which would typically be called technical blue collar roles, right? So
Yeah.
even though we have engineers out there testing and things of that nature, it's still considered to be more of the blue collar roles, and we definitely need more of that. And so our efforts, your efforts, and others out there that are doing this kind of stuff, it's for a reason. We need more folks. It's not because we're trying to sell you XYZ product. We just want this industry to be successful and have longevity. And it is a great space career-wise to be in. So couldn't agree with you more.
That's why we're excited to partner with you, because one of our requirements from Mark was to set up a job board. So now that we've partnered with you, we're just going to direct everybody to you, since you're in that landscape. And, that way, if they're coming through our VAP and they're looking for something, then they can come see you about positions and opportunities.
Absolutely. And here to help in any way, shape, or form that we can. So I love it. And I'm here to support in any way that we can to kind of help grow the industry and keep moving onward and upward,
Yes, sir.
All right, Drew. Well, that was an awesome one, guys. So again, many thanks to Drew for coming on, sharing his experiences. And again, if you're looking for that thermography or ultrasound training, IRISS.com. Go to that tab for training. Go to the Veterans tab. Reach out, get you some of that IR thermography or ultrasound experience, and get out there and do some work. And until next time, folks, Mike out.
Take care, everyone.